Hello, Pre-Calc BC. Today we are starting our probability unit. We are going to begin with sets and counting. So what is a set? A set is a collection of distinct objects, which we call elements. If a set has no elements, it is called the empty set. Or the null set, and it can be denoted by that symbol. Couple things, in a set we never repeat elements, we just list each one once. So we wouldn't say 1, 2, 3, 2, we just say 1, 2, 3. If sets A and B have the same elements, we can say A and B are equal. If each element of A is also in set B, then we say that A is a subset of B, and we'll get to notation on that in a little bit. If A is a subset of B, then every element of A is in B, and B may or may not have more elements. Okay, so let's go ahead and talk about that. Number one, find all subsets of the set 1, 2, 3. So all subsets are just the different options that you can have, and it didn't specify how many elements are in the subset, so you could just have 1, you could have just 2, you could have just 3. We could also have 2 elements, so we could have 1 and 2. We could have 1 and 3. We could have 2 and 3. So those are all of the subsets with 2 elements each. You could also have the subset B, all 3 elements. Or you could have the null set or empty set, which is none of those elements. Okay, so those are all the different subsets of this guy right here. Okay. Next we're going to talk about something that you probably saw in honors geometry, and we've discussed a little bit. This is intersection and union. I think you also did something with this in honors algebra 2 last year, with inequalities maybe. So intersection can be written like this. And this is referring to elements that are in both sets. So specifically you're looking for overlap. Where do these things overlap? Where do they have the same elements? Union is written like this with a U. And this is elements in both let's write that differently. In A, B, or both. So this is really like, this is when you're combining. Union means you're bringing them together. You're combining the sets. All right, so let's practice this. We have set A contains the elements 1, 3, 5, 7, and 9. Set B contains the elements 1, 5, 6, and 7. And set C has all of these elements. So the first thing we're going to do is find A union B. Union meaning we are combining, or we're looking at both sets together. So A and B, we want to take these two, we want to combine them. So we've got a 1, we do not have a 2, we have a 3, we have a 5. Notice they both have 5, but you only list it once. We have a 6, we have a 7, we have a 9. So basically it's like if you had like 2 cups and you pour what's in those 2 cups together. You have everything that's in both of them. Number 3 is a intersection with C. So this is saying specifically where do they overlap? What do they have in common? So we only care about the ones that they have in common, A and C. And the ones they have in common are they both have a 1, and they both have a 9, and that's it. So that's the intersection between A and C. All right. Next, we're going to do A union B, and then we're going to union that with C. So A union B, if you notice, we already found that. That's this right here. So I'm going to write that down. Okay, and we want to do the union with C. I'm going to write C down. And again, union means you're putting both of them together. You're combining them. So between the two of these sets, I have a 1, I have a 2, I have a 3, I have a 4, I have a 5, they both have a 6, I have a 7, oops, an 8, and they both have a 9. So there you go. All right, moving on. In sets, we designate what's called the universal set as U, which consists of all of the elements we want to work with. If A is a subset of the universal set, then we say that the complement of A, which can be written like this, is the set of all elements in the universal set, but not in A. Okay, so it's everything else that's in the universal set, but not in A. So let's practice this. This is our universal set. This is all of the numbers that we're dealing with. And then here's A, B, and C. We want the complement of C, which means I want the numbers that are not in C that are in the universal set. And so it's like, what are you missing from the universal set? That's what I'm looking for. You're missing the 0, you're missing 2, we have 3, we have 4, we're missing 5, we're missing 7, 8, 9. So that's the complement of C. You're comparing it to the universal set here. All right, number 6, we want the complement of A intersect B. So you're going to find this first. This is the intersection between A and B. Okay, meaning the overlap between A and B. What do they have in common? Well, let's look. Here's A, here's B. What do they have in common? They have a 4. And yeah, that's it. So they just have a 4 in common, and so that means the complement of that is everything that is not in here that is in the universal set. So that would be everything but the 4. So 1, 2, 3, 5, 6, 7, 8, 9. Okay. All right, be careful with 7 because you've got a lot going on here. We're going to take the complement of the complement of B union C. So start with the complement of B. Complement of B is everything that is missing from set B from the universal set. So you're missing a 0, you're missing a 1, you have 2, you're missing 3, you have 4, you're missing 5, you have 6, 7, 8, you're missing 9. So this is the complement of B. So now we're going to union that with C, meaning put them together. All right, so B, complement of B union C is, put them together, we've got a 0, we've got a 1, we've got a 3, we've got a 4, we've got a 5, we've got a 6, and we've got a 9. And now we want to take the complement of that. So again, the complement means what do you not have from the universal set? Okay, so the complement would be, we're missing a 2, 1, 3, 4, 5, 6, we're missing a 7, we're missing an 8. So this is the complement of B union C. All right, so we're going to be working with Venn diagrams a little bit at the end of this lesson and then the lesson tomorrow. So I just want to show you how to utilize Venn diagrams to show different situations. This notation right here means subset. This means A is a subset of B. So we're going to say that this whole rectangle here represents the universal set. And then if A is a subset of B, that means that you have set A, you have set A here, and it's a subset of B. So B is the bigger set, and A is inside of B. Here we have A intersects B equals the null set. Well, that really means that A and B do not intersect. So that would look like this. You just have A and B are separate from each other. They don't intersect at all. And again, this whole thing is called the universal set. All right, well, what if you just have A intersect B? The way we'll do that is you'll actually have them intersecting. Again, this is the universal set. And where they intersect would be right here, where they overlap. A union B, I'll draw them as overlapping again. They wouldn't have to be overlapping. But if you have A union B, it means like everything in them together. Okay, or you could have A and B, and it could be like that. It depends on the situation. All right, and then finally the complement of A, well, what would that look like? So if this is A, then the complement of A is everything in the universal set that is not in A. So that would be basically everything outside of A. My coloring isn't great, but you should get the point. All right. Okay. All right, so now we have a handy dandy counting formula. This is something you can memorize. I think it's just kind of common sense, but so I don't really think of it in terms of this actual notation, but if you find it helpful, then go for it. So this is saying that the number of A union B, so this is the number of whatever's in A or B, is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. All right, so in words, this is saying the number of elements in A or B is equal to the sum of elements in just A and just B. So that's this and this, the sum, minus the elements in both, meaning what they have in common. And the reason we're subtracting what they have in common is because otherwise you're going to be double counting those. Okay, they're being double counted. So that might be more clear when we use the Venn diagram here. So for 8 and 9, our last two, we're going to draw a Venn diagram to help find the missing information. We have that the number of elements in A is equal to 20. The number of elements in B is 18. The number of elements in A intersect B is 7. This is where they are overlapped. And we want to find the number of elements in A union B. This means both A and B together. So we know there's overlap, and that's where you should always start. There are 7 where they overlap. But you know that there are 20 in A, and so if there are 7 in this part, the overlap part, there have to be 13 over here. And then there are 18 elements in B. Well, 7 of them are in this overlap part, so there have to be 11 here. So when they're asking for the number of A union B, that's the number of elements in both A and B together. That would just be 13 plus 7 plus 11, which is 31. All right, so I kind of just used this, or did this with the Venn diagram. I didn't use our counting formula above, but if you didn't want to draw the Venn diagram, you could use that formula and it would look like this. That's the number of elements in A plus the number of elements in B minus their overlap. So that's 7. And that also gives you 31. And the reason that works is basically if we just added 20 plus 18, that gives you 38. What you're doing is you're really counting this 7 twice, right? You'd be doing 20 plus 18, but that 7 is really only there. It's the same 7 people or same 7 whatever it is. So you can't add it twice. That's why you have to end up subtracting it off so that you aren't double counting it. Okay, that's what's really happening there. I prefer to go from the picture. Okay, last one. Really quick, number of element B, we're going to change this to 53 because I like the way it comes out better. So change that to 53, and right, it was just 52 before. Yeah, give it one more. One more for set B. All right, and here we go. You're going to notice there is the universal set this time. So that's 100 is in the whole rectangle. And just to be clear, this 100 is meaning, it doesn't just mean the outside part. Okay, so maybe we want to put that 100. That's like everything. Okay, the whole rectangle is 100. That's how I'm trying to represent that. All right, so the number of elements in A is 35. The number of elements in B is 53. The overlap where they are intersecting is 18. Again, that's where you always want to start. And we want to find the number of elements of the complement of A union B. Well, you should find just A union B first. And then the complement will come into play with the universal set. So we won't use this 100 until the end. Okay, so again, if you want to use the Venn diagram, you know that there are 18 where they overlap, but there are 35 total in set A. So 35 minus 18 gives you 17 that are left in this non-overlap part. And then in B, we have 53 total items, but 18 of them are in the overlap. 53 minus 18 gives you 35 that are left in this part. Just go ahead and check. 17 plus 18 is 35. Yes. 18 plus 35 is 53. Yes, we are all good. So now the number of elements in A union B, we can just add those up. 17 plus 18 plus 35, and that my goal was to make 70, which yes, that would be 70. Or you could use the handy dandy formula, and that's the number of elements in A plus the number of elements in B minus their overlap, and 35 plus 53 minus 18 is also 70. All right, but remember, you're not done because we want the complement of this. So the number in the complement. So if there are 70 total pieces in A union B, and there are 100 in the universal set, then we just have to do 100 minus 70 gives you 30 for the number in the complement of A union B. So that means there are 30 pieces out here, 30 whatever people or crayons, I don't know. All of these numbers should add up to 100, which is representing the whole set. All right, so there you go. I hope that was exciting. You do want to do your day 1 homework as well. It is on page 881, and have a great 3-day. Bye-bye.